Hi guys. Let's get rid of that. Hi guys, we're going to go over your examples on the top of your electron configuration practice assignment. So before we do electron configuration, we need to talk about our 3 rules for electron configuration in using these orbital filling diagrams. The first one is the Aufbau principle, which states that we have to do the lower levels before we do the higher levels. So we have to start with our 1, we have to do 1s and then 2s and then 2p and then 3s and so on. So you have to do them in order. And that's where you see those Aufbau diagrams with the arrows that show you the order you do them in. The Pauli exclusion principle says that each orbital, each one of these squares, can only hold 2 electrons. And then those electrons have to go in opposite directions, so you have to have ups and down arrows. And then Hund's rule states that you have to do singles before doubles. So I have to have 1 in every box before I can do 2. And in the s orbitals, they only hold 2, so that makes it easier. But when we get to p orbitals and d orbitals where they hold a lot more, it'll be a little bit more. You have to do all of your ups before you can do your downs. So you need a periodic table to do this, and I know that this is backwards, but I'm still going to explain to you where your blocks are. So your S blocks is this first 2 rows, the one that starts with hydrogen and the one that starts with beryllium. And then helium is also part of your S block. Your P block is this section here. And that would be the rows that start with boron, carbon, nitrogen, oxygen. That whole section is your P block. Your D block is your transition metals in the middle. And then your F block would be the lanthanides and the actinides, with these 2 ones also in part of the F block. And there are rules when we get to that on what you subtract and what you add. And we will go over that when we get there. But right now you're going to be doing orbital filling diagrams, so it's a little bit easier. When you get to your D block, you subtract 1 from your principal energy level, which is the row on the outside. And when you get to your F block, you're going to subtract 2 for the numbers. So this one is actually F4, or 4F, and this one would be 5F, even though they're technically parts of rows 6 and 7. And we're actually not going to do any electron configuration, I think, that involves this stuff. We'll try to leave that part out because it's a little bit more complicated. So let's go over how to do electron configuration. And again, I do need my periodic table. In order to come up with the number of electrons, it's my number of protons, which is my atomic number. So cobalt is number 27 on the periodic table. That means that I have 27 electrons to fill in. Please let me type. Okay. I did include these arrows for you to copy and paste so you can do your electron configuration. Remember, I have to do my ups before I do my downs. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1 wasn't quite big enough. Oh well. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So now I have my 27 electrons. So to write my electron configuration, what I'm going to do is I'm going to write my 1s, and then I have 2 electrons, which I write as an exponent. Then I have 2s, 2 electrons as an exponent. 3s, 2 as an exponent. 3p6, 4s2, and then 3d7. And then to check my work, I can add up all of my subscripts. I'm pointing at my screen like you can see it. I can add up all of my subscripts, and that should equal 27. I also know that if I go to the 3D block, which is this one right here, so it's row 4, 3D block, and I count over 7, 1, 2, 3, 4, 5, 6, 7, I'm on cobalt. I didn't show you that. So here's 3D, so it's row 4 minus 1 would be 3D. It's 1, 2, 3, 4, 5, 6, 7 is cobalt. All right, let's do silicon now. Silicon is number 14 on the periodic table, so I have 14 electrons to fill in. So for my S blocks, I'm just going to copy and paste those really quick instead of doing individualized because I'm hoping you get it now. And then I'll do individualized when I get to my P blocks. So 1s2, I have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's write out my electron configuration for silicon. So I have 1s2, 2s2, 2p, 6, 3s2, 3p2. So I can check my work again by adding up all my subscripts to get 14. I can also go, okay, the P block is this one. 3P would be the third row, so 1, 2, 3. Sorry, this is the P block, third row, 1, 2, 3, and then I'm going over 2. 1, 2. Oh, I'm sorry. This is the third row. Reverse what I said. Third row is 1, 2, 3, and then I go over 2. 1, 2. This is silicon. All right. Now we're going to do noble gas configuration. So noble gas configuration is where I take my electron configuration and I'm going to shorten it. And I get to shorten it using the noble gas of the row before. So if I wanted to write silicon from before, for my noble gas configuration, I'm going to start at neon and then write the rest of the electron configuration. So it's the row above it. Now, the exception to this is when I have an actual noble gas. When I have an actual noble gas, I have to write the configuration. I can start at the electron configuration of the noble gas above that, and then I still have to finish it out. So let's do krypton. Krypton is number 36, and it's a noble gas. So I'm going to start with the row above, which is argon. So I'm going to do bracket. Oh, no. Go back. So I'm going to do my bracket. And then I'm going to write AR for argon. Ooh. All right. So then after I finish argon, which is here, I'm going to go to the next row. So that one's in row 3. I'm in row 4. So I'm going to do 4s2. So 4s2. 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3D10. And then 4P, 1, 2, 3, 4, 5, 6. 4P6. And then how do I check my work on these? Excellent question. So you're going to take the number of electrons, that's argon, which is 18. I have a calculator somewhere. Here it is. Okay. That was my thumb. You're welcome. So argon's 18 electrons, and then I would add up 12 plus 6, so 18. So 18 plus 18 is 36, and that is krypton's atomic number. Okay, let's do sulfur. So sulfur is number 16 on the periodic table. So we're the noble gas, the row above that would be neon. Okay, so neon's here. Now we're going to go to row 3. Sodium is So we're going to do 3s2. And then 3p, 1, 2, 3, 4, 3p4. And I'm going to go ahead and reference a slide in your notes. Slide number 18 on your notes for this unit is a periodic table that has the electron configurations written on it. So all you have to do is like look at it and match it up to the element. I know you're going to have questions about this because it's kind of funky. You can message me and I will be happy to answer any questions you have. Hopefully this sort of helps make sense. I'll post another reference video of someone else going through this in hopes that it'll also help you out. But that's how you do your examples on this assignment, and your assignment is going to be based on these examples. So good luck. I know you guys are going to do great. I'll talk to you later. How do I exit?